Chantal has two candles, one of which was 32 centimeters longer than the other. She lit the longer one at 3 p.m. and lit the shorter one at 7 p.m. At 9 p.m., they were both the same length. The longer one was completely burned out at 10 p.m. and the shorter one completely burned out at midnight. The two candles burned at different rates, but constant rates. What was the sum of the original lengths of the two candles? So I've got candle number 1 and candle number 2. I'll let the original length of candle number 1 be x, and candle number 2, the original length, was x plus 32. So this question is telling me to find the sum of the original lengths, which will be x plus 32, which is 2x plus 32. So obviously I have to figure out the value of x. Before I begin, I'd like to explain this question a little bit as to how to approach it by giving it some numerical values. Let's say my candle is 20 centimeters long, and the rate at which it burns is 2 centimeters per hour. And I ask you, after 2 hours, what is the length of the candle? Well, it would be 20 centimeters minus 2 times the rate, which is 2, right? So that's going to be 20 minus 4, which is 16. So after 2 hours, the candle is only 16 centimeters. All right? So with a numerical example, I hope you can understand how we're going to do this. So first, before I get into the rates, let me just write out the times. So at the very beginning, we've got x and x plus 32. And the very beginning for candle number 1 is 7 p.m. The very beginning for candle number 2 is 3 p.m. All right. Now they are moving forward a little bit, and they're saying 9 p.m. for candle number 1. And they're saying that at that point, they are both the same length. All right. So I'll call it y. I don't know. I have no idea what the length is. So we'll just say y, because they're both the same length. Therefore, I can call both of them y. And then at the very end, they're saying that eventually the length becomes 0. So for candle 1, that happens when? Shorter one completely burned out at midnight. So 12 a.m., right? Midnight is 12 a.m. And then 0 for candle number 2, which is 10 p.m. Okay, so that's the setup, right? Okay, now we're going to get to this whole story right here. So for C1, we have x for the original length. But then after 2 hours, from 7 to 9 p.m. is 2 hours, what will be my length? Well, exactly what I did here. It will be x minus 2 times the rate. And I'll call it rate 1 for candle 1. And that is equal to y. Okay? Nothing fancy, just exactly what I did over here. And then similarly for C2, that is 6 hours, right? 3 p.m. to 9 p.m. It'll be x plus 32 minus 6 times R2, where R2 is the rate that the candle 2 burns at. All right? And then for this guy right here, 0, that is 7 to 12 is 5 hours. So it's x minus 5R1 is equal to 0. And then for this guy, it's 3 to 10, which is 7 hours. So x plus 32 minus 7R2 is equal to 0. So these are our equations that we are going to use to solve. All right, so here we go. Let's solve this now. In any order is perfectly fine. I immediately see this as being very helpful, that x is going to be equal to 5R1. Okay, and that's going to help me out, I hope. And this is what I'm going to do. Since these are both equal to y, I set them equal to each other. So we get x minus 2R1 is equal to x plus 32 minus 6R2. All right. Well, get everything in terms of x if possible. R1 I can get in terms of x, it's going to be x over 5, like that. And this is x plus 32 minus 6r2. R2, yeah, I can get in terms of x with this equation. So that's going to be, let's see here, x plus 32 is 7r2. So that means r2 is x plus 32 over 7. So x plus 32 over 7, like that. Okay, so now we just have to solve this. Multiply everything through by 35. That'll help get rid of both fractions. And if you do, you get 14x, and this will be 35x, like that, plus 1120 minus 6x plus 30x minus 960. Okay, and then if you collect like terms, you get 16x is equal to 160, and therefore x is equal to 10. There we go. So going back to our original, 2x plus 32 looks like 20 plus 32, and that is 52. So there we go. Number 25, the answer is E. In the diagram, the shape consists of 48 identical cubes with edge length root n. Entire faces of the cubes are attached to one another as shown. What is the smallest positive integer so that the distance from P to Q is an integer? Well, we want to go from P to Q. And if we do that, we can draw a straight line like that. Now, how do we figure out that distance? Well, we're going to use Pythagoras. We're going to use this line, and then we're going to use this line right here. That triangle. And that triangle has basically a right angle right here. I know it doesn't look like it, but trust me, because the line that I drew on the bottom there, that's basically at the base. But we've got a little bit of a issue that we don't really have enough information yet, but that's okay. We can create information by extending this to look like that. And that will help me. Now let's label this. And PQ, let's just call that R. So QR is 1, 2, 3, 4. 4 of those sides, and each side is root n. So that's 4 root n. From here to here, that is going to be 1, 2, 3, 4. So again, 4 root n. And we'll just call that 4 root n for now. And then from here to here, that's going to be 1, 2, 3, 4, 5, 6. 6 root n, like this. So now we figure out PR squared. PR squared is 6 root n squared plus 4 root n squared. And that's going to be PR squared is 36n plus 16n. And that is 52n. So now I can go ahead and figure out PQ squared. PQ squared is going to be QR squared plus PR squared. Well, QR squared, that's 16 times n. PR squared, well, that's just 52n. And there we go. So that's what? 68n is PQ squared. So PQ will be the root of 68n. And they want this to be an integer. Okay? So we've gotten this far. How do we make this an integer? Well, first of all, 68 is equal to 2 times 2 times 17. If 68n is a perfect square, then the square root of it will be an integer. But 68 is not a perfect square. It's 2 times 2 times 17. So what can n be? Well, this is a perfect square. If I add on another 17, then I've got a perfect square. right? Because 2 times 2 is a perfect square, and 17 times 17 is a perfect square. So when you multiply it all together, it equals a perfect square. So that means that n, if n is 17, it will make this a perfect square. And we can verify that. Let's set n equal to 17. And then take the square root. And when you do, you get 34. And that is the smallest number I can use. I can use larger numbers, but 17 as n is the smallest number I can use. And that's it. That's pretty much what they wanted us to figure out. What is the smallest positive integer n, so that PQ is an integer? So number 23, the answer is A. 4 pieces of lumber are placed in parallel positions as shown, perpendicular to line M. Piece W is 5 meters long. Piece X is 3 meters long, and its left end is 3 meters from line M. Piece Y is 5 meters long, and it is 2 meters from line M. And piece Z is 4 meters long, and it is 1.5 meters from line M. A single cut perpendicular to the pieces of lumber is made along the dotted line L. The total length of the lumber on each side of L is the same. What is the length in meters of the part of piece W to the left of the cut? So, first thing we'll do is start labeling this. This whole thing they're saying is 5, but I'm going to label the part that's left to the cut X, because that's what they want us to find. Essentially, that question just boils down to find X. Well, that means that to that is X. So that means this part here that is right of that dashed or dotted line, it's got to be 5 minus X. Okay? So here we go. This whole thing is X, but we know that from here to here is 3. So this part has got to be X minus 3. Okay? So here we go, same story. This whole thing is X, but from here to here is 2. So this part has got to be X minus 2. And then from here to here is X. This is 1.5. So from here to here has to be X minus 1.5. All right. Now we get to the other side. Well, this part we already labeled 5 minus X, so that's done. This, well, the whole thing is 3, and this part is X minus 3. So this part has got to be 3 minus X minus 3. So it becomes 3 minus X plus 3, and that is 6 minus X. Okay, so I hope you understand how I did that. This whole thing is 5, as they tell us. From there to there is X minus 2. So from here to here has to be 5 minus X minus 2. So it becomes X plus 2, which is 7 minus X. Right? And in a very similar way, that whole thing is 4. From there to there is X minus 1.5. So therefore that part has got to be 4 minus X minus 1.5. But if you take it out of the brackets, it becomes 1.5 like this. And that is, of course, 5.5 minus X. So that's the setup of the question. Now, this piece of information is very important, obviously. It tells us that what's on the right side is equal to what's on the left side. So what is on the right side? We got these 4 guys, so let's add them up. We have X plus X minus 3 plus X minus 2 plus X minus 1.5. And that is equal to what's on the other side, the right side. On the right side, we have this, 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 and this. So let's add those up. 5 minus X plus 6 minus X plus 7 minus X plus 5.5 minus X. All right, now it becomes just straight algebra. Adding this, we get 4x minus 6.5. And on this side, we get 23.5 minus 4x. Bringing it over, 8x is equal to 30, and therefore x is equal to 30 over 8. And 30 over 8 is 3.75. So there you go. That's what they wanted. 3.75 is what they wanted. Find x. So number 23, the answer is D. A rectangular piece of paper ABCD is folded so that edge CD lies along edge AD, making a crease DP. It is unfolded and then folded again so that edge AB lies along edge AD, making a second crease AQ. The two creases meet at R, forming triangles PQR and ADR, as shown. If AB is 5 and AD is 8, the area of quadrilateral DRQC is in centimeters cubed. DRQC, so we're interested in that right there. So I blew the diagram up a little bit. DRQC, this is what we are interested in. And the first thing I can do is just break this up into two sections like that. And if you do, half of it, or not maybe half of it, but at least part of it will be quite easy. This is AB, and that's 5. And they tell you that AD is 8. So immediately we can label those. Now, notice in this diagram right here, up here, that CD was here. And then you folded it and CD came up here. So when you do that, what you've basically done is formed a square. And because you formed a square, this is the same as that in terms of its length. Correct? So basically what that means is that since AB is 5, CD is 5, right? Because this is a rectangle. And when you folded it up and CD kind of came up here, right? This was CD. If you look at it from that perspective, that CD is also going to be 5. Correct? So that means that from here to here is 5. And since P is exactly across, like if you were to draw a line across like that, P is exactly across, that means from P to C is also 5. So if I were going to draw a distance, that's also 5. Okay? So that's the first thing you have to establish. And in a very similar way, for this crease that brings it to Q, it's exactly the same. From B to Q, it's also 5. Okay? Now that allows us to figure out the distance from B to P. If this whole distance is 8 and this distance is 5, then that means B to P is 3. And in a very similar way, you can figure out that Q to C is also 3. And therefore P to Q, that distance, is 2. Okay? So the very first thing in this red quadrilateral we can figure out is the area of this triangle right here. So that triangle, which is DCQ, is just 1/2 base times height, and the base is 5, and the height is 3, so that's 7.5. Okay? Now we have to figure out this triangle right here. To figure out that triangle, what I'm going to do is first figure out the triangle PQD, which is this guy right here. PQD is right there. From that, I will subtract this one, PRQ. So PQD minus triangle PRQ, and whatever that is, I will then add to the 7.5, and therefore I'll got my answer. Okay, PQD is 1/2 base times height. The base is PQ, which is 2, and the height, I can use this distance, D to C. So that's 5. Now we come to not necessarily the most difficult, but definitely a little bit of thinking involved here, PRQ. How do I figure out the area of PRQ? I have the base, that's 2, that's not a problem. But the height, from there to there, how do I figure out the height? Well, I'll just draw in the height in red. First, let me remove that 2 there. Okay, so we're going to need to draw in the height. So here's the height right there. Okay? And let's blow this up a little bit. Now, how do I figure out that height, that red line? Well, this is where angles come in. This angle right here is going to be needed. How do I figure that out? Well, remember, this essentially, when it was folded, formed a square. So that crease is the diagonal of a square. So if you were to look at that angle is 45 degrees. And because it's 45 degrees and this is a right angle, this is also 45 degrees. So this is an isosceles triangle where this side is the same as that side. And this whole side was 2, so therefore half of it from here to here is 1. And therefore this is also equal to 1, since it is the other side of the isosceles triangle. So there you go, you just got your height. Height is 1. So I can now figure out the area of PRQ. PRQ is 1/2 base times height. The base is 2, and the height is 1. And that looks like it equals 5 minus 1, which is 4. So now to figure out the quadrilateral DRQ, I just have to add this, and if I do, I get 11.5. And therefore, the answer to number 25 is D. A triangular prism has a volume of 120 centimeters cubed. Two edges of the triangular faces measure 3 and 4 centimeters, as shown. The height of the prism in centimeters is. The volume of this shape is calculated as follows. The area of the base times the height of the entire shape. Now the volume of the height, I can label right here H. Now the area of the base is right here. This is the base, right? That's the base, and that's also a base. Either one, same dimensions, 3 by 4. So this is 3, and that's 4, and that's 4, right? No problem. So the area of the base is just a triangle. So it's 1/2 base times height, and you can use either one, 3 for the base, and height you can use 4. And then I have to multiply all this by H. The volume they have given me is 120. So there you go. That's the equation. Solving for this, I get 240 is equal to 12H, and therefore H is equal to 240 over 12, and that means H is equal to 20. So number 21, the answer is B.